Hi everyone, welcome to this video lecture. Myself, M. Krishna, working as assistant professor in Triple E Department, St. Peter's Engineering College, Hyderabad. Here in this video, I am going to explain about cycloconverters. A cycloconverter is a direct frequency changer that converts AC power at one frequency to AC power at another frequency by AC-AC conversion. Actually, the cycloconverters are used in high power applications, driving a synchronous and induction motor. They are usually phase controlled and they use thyristors due to their ease of natural commutation. That we can see in this diagram. This is the input supply. It is a cycloconverter and we are getting the output value at a different frequencies. Basically, these cycloconverters are two types: step-up cycloconverter and step-down cycloconverter. Step-down cycloconverter means the output frequency from the cycloconverter is always less than the input frequency. That is, F0 is less than the Fi. In case of step-up cycloconverters, the output frequency is always greater than the input frequency. That is, F0 is greater than Fi. And these are the basic classification where the frequency conversion takes place. Generally, these are single phase cycloconverters and three phase cycloconverters. To understand the principle of operation of cycloconverter, the single phase to single phase conversion is one, and and the second one is single phase to three phase and three phase to single phase. These are the different configurations are available to convert the AC signal into AC at a different frequency values. First we will see the single phase converter. This converter consists of back-to-back connections of two full wave bridge rectifiers. You can able to see that in the diagram. Look at this. This is one converter, this is another converter. This converter is called P converter, means positive converter. This converter is called negative converter, N converter. And single phase to single phase conversion takes place using this configuration. So this can we can see in the waveforms. During this, P conversion takes place here. P converter on during these cycles, and N converter is for this during the cycles. Look at this operation. This thyristor means when the AC supply is applied across this, the current is coming like this, entering into this thyristor and going to the load and back to the thyristor T2, we can say this, and enter into B terminal back to the source. Like that, it is having a closed path. At the time, we are getting the output like this. When thyristor T1, thyristor T2 are going to be on, we are getting output like this. After that, we are making the thyristor T1 and T2 off naturally, because it is going to be 0 here directly. When it is going to be 0, then automatically the voltage across thyristor T1 and thyristor T2 are going to be 0. Immediately, after some alpha values, T3 and T4 are going to be triggered together. Thereby, the current is coming like this and enter into T3, and through the load it's coming back to the T4 and back to the source. Like this, it is having the path. In this condition also, the current is entering into the load in the same direction and having the positive side voltage like this. This is the output when T3, T4 conducting. After that, again T1, T2 are going to be triggered to get this output, and T3, T4 are triggered to get this output. After that, we are trying to close the operation regarding to P converter, and we will start the conversion from the N converter. In this case, this conversion takes place when these two are going to be turned on. This conversion, the second one is will get after this one. These two are going to be turned on. Like that, next for half cycles, we are going to turn on the one pair of thyristors from the N converter, and for some other half cycle we are going to turn on the remaining one pair of thyristors which are there in the N converters. In this way we are going to get the output wave like this. Means time period is less, but the time period is more here, means frequency is less, called step down cycloconverter. And this is the input voltage we are applying to the cycloconverter. The RMS output voltage can be found like this: V naught equal to Vs of 1 upon pi into pi minus alpha p plus sine 2 alpha p upon t under the root. And when P converter operating alone, the output voltage is positive half cycles with the average output voltage of Vd1 equal to 2Vm upon pi cos alpha. Step down converter, the output frequency is always f naught is equal to 1/4 fi, means f naught we are getting around 4 times less than the input frequency. When N converter operating alone, the output voltage is equal to Vd2, that is minus Vd1. This is the average output voltage. And coming to 3-phase to single phase conversion, there in 3-phase to single phase conversion, the cycloconverter consists of 2 3-phase half wave control rectifiers as shown in the figure. One converter is for positive group and the other converter is for the negative group. When P converter operating alone, positive voltage K appears. Positive voltage K appears across the load, and when N converter operating alone, negative voltage appears across the load. Means for this number of half cycles we are going to on the P converter thyristors. For this number of half cycles we are going to on the thyristors belongs to N converter to get the output voltage. Here are the same thing. Time period is very less, but we are getting the time period is more in case of output voltage, thereby the frequency is going to be reduced. Positive group converter operating, negative group converter is idle. When it is happened, this is the output. We are getting the points like that: A, B, C, D, E, F. For that, these are the some idea about the mathematical things. When the negative group converter operating, positive group converter is ideal case. In that case, this is the output that we are getting: K, L, M, N, O, P, Q, R. With that, when we take the average of this is the value. This is the positive half cycle. This is the negative half cycle. Combinedly, we have the one full cycle having the huge time period. Thereby, frequency is going to be reduced, called step down cycloconverter. When we see the 3-phase to 3-phase cycloconverter, it's like a M type midpoint type cycloconverter, and you can see if the output of 3-phase to single phase converters of the same kind are connected in delta, and if the output voltages are 2 pi upon 3 radians phase shifted from each other, the resulting converter is a 3-phase to 3-phase converter, cycloconverter. We have another type of 3-phase to 3-phase cycloconverter is obtained by using full wave bridge rectifier as shown in the figure, and this type of frequency changer is using 36 thyristors. The output frequency is less than the input frequency. The applications of cycloconverters are many. Among them are we are going to discuss a few things. These cycloconverters are mainly used for producing low frequency AC voltages. The main application of such requirement is the electric traction system, where the low frequency, typically 25 Hz to 16 to 3rd Hz, are preferred at 25 kV voltage level. In such systems, 3-phase squirrel cage induction motor is controlled by